y would always be increasing since this was always positive. Okay, so that's how you do that. What we're seeing, that's just a review pretty much, because that's chain rule.
Are you recording?
Yeah, I am now. That's a review of chain rule. Now what we're going to be seeing today is something called implicit differentiation. So we're going to be seeing graphs that aren't functions. Here, like this graph here, x cubed plus y cubed minus 9xy equals 0. This is the graph for it. You can see it's not a function. It has a loop in it, so it doesn't pass the vertical line test. It still has a derivative though. Okay? So here, if you were trying to take this equation and solve it for y, does anyone think they could?
Not easily.
Not easily. Does anyone think they could, period? Anyone feeling confident? Want to come up here and show me?
I think Clayton could probably.
Clayton could probably do it. Let's volunteer him. You probably couldn't, unless you know more algebra than I think you do. So it's because there's a y cubed and there's also a y. There's two different pieces there with y in it. You're not going to be able to isolate y. It's just not going to happen. So instead, we don't try to, because it would be just too difficult. So what we do is we look at it by taking the derivative in terms of x. And I'll show you kind of what that looks like. It becomes kind of a complicated, well, it looks complicated at first, but it's just a technique that you use, and you just use the same technique every time. So you can tell it's a question like this when you have an equation where you can't solve for y, or that solving for y would be hard even. Okay, so usually what it is there's x's and y's mixed together, like here where we have 9xy. If I see something like that, I know it's implicit differentiation. Okay, so let's look at a couple, and I'll show you how to do it. So this one is actually not something I would have to do implicit differentiation with. X squared plus y squared equals 25. I could solve for y there. It's not that hard. I would just subtract x squared and take the square root, right? But it's kind of a pain. Instead, implicit differentiation is actually a lot easier. Ryan, are you ready for this? Okay, look at the screen. Okay, so if I'm doing implicit differentiation, basically the trick is it's product rule, but it's kind of weird. It's that we're taking the derivative in terms of x, but there's y's involved. So we have to do chain rule and product rule and stuff like that. And when you think about any time you have to differentiate a y, you have to remember to do something special. So I'll show you what it looks like. So I take the derivative of x squared, which is 2x. Now this is when it gets weird with the y. So x is, if there's just an x, you just do it. It's totally normal. Now once you get to a y, this is when things get a little bit funny. You take the derivative in terms of y. So I'm like, okay, well y squared would be 2y. But then I have to do chain rule. So I have to multiply by the derivative of this. Okay, the derivative of y. Because I don't know what the derivative of y in terms of x is, because I don't know what y is equal to. So to hold its place, what I do is I just multiply by y prime. Okay, it is just an extension of the chain rule, but it looks really weird. And don't try too hard to understand it. Just any time you take a derivative in terms of y, put y prime. That's the trick. So if I'm going to do 2y, I write y prime afterwards. Okay, and the reason for it is chain rule, but if you don't understand that, it's fine. Now, then I take the derivative of 25. What's the derivative of a constant?
0.
0. Now what you want to do is, once you've done that, you want to isolate y prime. So what would I do here to isolate y prime? Move the 2x over, so I have 2y, y prime equals negative 2x. And then what? Divide by 2y, divide by 2y. So I get y prime is equal to negative, what would 2x over 2y simplify to? X over y. Here we go. Okay, and they want it at 0.3, negative 4. So there, if I want to do that, I'm like y prime 3, negative 4 is equal to negative 9 over negative 4, so positive 9 over 4. Okay, there we go. It's wonderful. Okay, we did it. Okay, and this works. I could show you that this works by solving for y.
Wait, why is it negative 9?
Because there was a negative out front. It was
No,
negative
why-
x over
why
y.
is it 9?
Oh, yeah, why is it 9?
Yeah, I was wondering if it's good.
Good question. It should just be 3. I don't know why I did that.
I always thought that.
Probably. Okay. 3 over 4. Okay, so if instead we wanted to solve it just by solving for y first, if I started with this equation, I could solve for y. I'd have y equals the positive or negative square root of 25 minus x squared. Okay, so anytime you take a square root, what you have to remember is that you have to take both the positive and the negative square root of it. So here we do end up with 2, but even if I just looked at the positive root, why in this case do you think I'd just look at the positive root? Actually, you know what? I don't even think I should look at the positive root. Let's look up for a minute. The point, 3, negative 4. Okay, that point 3, negative 4 would be on the bottom part of my circle. 3, negative 4 is down here. So it's actually on the negative part. So I should look at the negative root. Okay, so anyway, you wouldn't know that. That's why implicit is better, because if you use implicit, you don't need to worry about things like that, like which root should you look at. But I would look at the negative root. So if I look at the negative 25 minus x squared to the power of a half, and if I do y prime with that, I get negative a half 25 minus x squared to the negative a half times negative 2x, and that's kind of ugly, but I can deal with it. Okay, so this would cancel off with this. I'd end up with y prime is x over the square root of 25 minus x squared, and we wanted it at the y value of 3. So if I look at y prime of 3, I get 3 over 25 minus 9, which is 3 over 4, which is the same thing as I got before. So I get the same answer. So this did work, is what I'm proving to you. Implicit is a lot easier than doing this. So you should be using implicit when you have x's and y's on the same side of the equation, unless y is very simple to solve for. Let's look at some other examples, because that's a very easy example. This is a more typical one. Haley, are you ready?
I'm writing it down.
Okay. So we have x squared minus xy plus y squared equals 7. Okay, so this is a very, very typical implicit differentiation problem. I really would like everybody to be able to do this, so watch me carefully. So if there's just an x involved, you just take the derivative of it. So x squared is just 2x. Now, when we have yx in the middle, it becomes harder because that is a product. So when you take the derivative of product rule, you have to use the product rule. So we have here, what I do, I actually don't really think about the product rule when I'm doing it, to be honest. I'm not sure how I was taught this, but I must have been taught it kind of funny. I don't think about the product rule when I'm doing it. All I think about is that first I'm going to take the derivative in terms of x, and then I'm going to take the derivative in terms of y. So I look at just the x, and I imagine that the y was like a constant. Okay, so if I took the derivative, and really what I'm doing is I'm doing f prime g. So if I'm thinking of f prime here, what would be the derivative of x? 1. So it would be negative 1. I just put a minus, though, since it's minus anyway. Okay, so it's minus 1y, because that's f prime g. Okay. Then you have to do g prime f. So g is y. What would g prime be?
1.
No.
It's
Y prime. It is y prime. Okay, so when you take the derivative of y, it's not in terms of y. So it always has to be y prime. You could think of it as 1, but you have to think of it as 1 y prime. anytime you take a derivative of y, it needs to be y prime. So it's going to be g prime f, which is y prime, and negative x. So it's going to be negative x y prime. Okay? We'll look at some more examples afterwards because I know it is a little confusing. But it's thinking about it when you take the derivative of y, it's always y prime. Okay? Then I take the derivative of y squared, which is 2y. But since I took the derivative of y, I have to put y prime. And then it equals 0. These tend to equal 0. Like there usually is a constant on one side. Not always, but usually.
So you put
What
2y
happened with 7?
and y?
The derivative of 7 is 0.
Oh, okay.
You put 2y, because that's the derivative, and then you multiply it by y prime. Okay? Because it's like chain rule. Okay? It is confusing at first, but I promise it's not that bad once you've done it a bunch. Okay?
Callie.
Yep. Clayton?
So you could think of it as taking the derivative of y in terms of y, but then just adding a y
Prime, yeah.
afterwards?
Yes. That is kind of how I always think about it. I'm just like, anytime I take the derivative of y, I put y prime.
Okay.
Okay? And that's all, like, I just remember, anytime I'm doing y, I have to put y prime. Okay? Now, you want to isolate y prime. Now, there's going to be a slight problem with that. Ryan, what problem am I going to run into when I'm trying to isolate y prime? Maybe you need to move seats.
No, I got it. So for the second one?
Yeah, I want to solve for y prime. What am I going to run into? What would you do if I asked you to solve for y prime here?
Y prime. For what exactly?
Yeah,
You asked the wrong person.
I asked the right person. Clayton?
Is it because there's like a negative xy prime and a 2yy?
Yeah, there's two different spots in my equation that y prime shows
I
up.
thought we were trying to solve one.
Yeah. So I'm looking to isolate y prime. So you need to move anything, first of all, that doesn't have a y prime in it. You need to get rid of it first. So I need to move 2x, and I need to move negative y. So I would add y and subtract 2x from both sides. Okay, so I'd leave the y prime stuff over here, and I'd add y and subtract 2x. Okay? Now, in order to solve for y prime, because of what Clayton just said, that there's two y primes there, there's one in each of those terms, what you do is you factor out y prime.
Wouldn't you?
Okay? When I would factor out y prime, is what I would do.
Why wouldn't you divide by 2y?
I can't divide by 2y because there's this negative xy prime here.
It has to be able to work to both sides.
Yeah.
Oh.
So what I do is I factor out y prime. So once I factor out y prime, what would be left in the brackets? Negative x plus 2y equals y minus 2x. Now I'm able to divide.
Divide by negative x plus 2y.
That's right. So I will divide by negative x plus 2y or 2y minus x, however you want to think about it. Okay, so y prime here is y minus 2x over 2y minus x. Okay, Ryan, have you written this down?
Yeah,
The most feeble answer.
Okay, so the question is asking us to find the tangent at the point negative 1 comma 2. So I should put that in. Negative 1, 2. So it's 2 minus 2 plus 2 over 4 plus 1. So it's 4 over 5. Okay? So, yeah, so you just do this the same way every time. We'll look at some more examples. It's a really, once you've done it a few times, it's really not very hard. But the first couple times you see it, it looks very difficult. So don't worry if you're like confused right now. You should be writing it down though. If you're confused because you're not paying attention at all and are just being obnoxious, then that's bad. If you are confused, even though you're trying, that's okay right now.
How does the 2y minus x become 4 plus 1?
2 times 2 is 4,
Oh,
minus negative 1 is plus 1.
sorry, thank you.
It's okay. Just do it as slow as you have to when you plug the numbers in. Okay, whatever you have to do to get them right. Otherwise you'll accidentally put a 9 somewhere. Okay. it happens. Okay, so this is a pretty straightforward question, though. This is a very typical one. Like, this is exactly what you could kind of expect. Okay, so here are the actual steps written down for you. So differentiate both sides with respect to x. Collect the terms with y prime on one side of the equation. Factor out y prime. Solve for y prime. Those are the steps. They're pretty straightforward. The part that people will usually have trouble with is the first part, is differentiating both sides. So let's see, this one's very simple actually. So let's try, everybody try it right now by yourself. Okay, so y squared equals x. Try differentiating that using this process. You're doing it in your head, Lauren?
Isn't gonna be 2 y prime?
Yeah.
I think I've got it.
I think you've got it. What do you think you have?
I think I have, okay, I don't have it. Hold on. Is it 1 over 2y?
Yes.
Oh, I'm stupid.
Okay, so let's go over the answer of how you do it. So you take the derivative of the left side of the equation. That's going to be 2y, and because I took the derivative of y, I put y prime. Equals, what's the derivative of x? 1. And then all I do is divide by 2y, so it's 1 over 2y. Okay, and that's everything. Okay? So that is obviously a very simple one. You would expect them to be harder, but that is the general idea of it. Okay, so if we look at this one has a sign in it, so I would expect some amount of panic. Okay. So what will be the derivative in terms of x of 2y? 2y prime. Fantastic. Okay, so Lauren has it now. So hopefully people are starting to see anytime you take a derivative that involves y, you put y prime. So it's 2y prime equals, what will be the derivative of x squared?
2x.
2x. And then sine y. The derivative of that would be cosine y, y prime. So anytime you take a derivative with y, you multiply by y prime, okay? Every time. So the derivative of 2y, you might be like, oh, that's 2, but since there was a y involved, you put y prime. Now, the second step after I differentiate is to collect the y prime terms on one side. So I need to do that here. So what would I do in order to do that? Yeah, move cosine y, y prime, or you could move the 2x and the 2y, whatever you prefer. So I probably would just subtract once, so I would just subtract y prime cosine y, but it doesn't matter. Okay, now what do I do?
Take out y prime.
Take out a y prime. So I have 2 minus cos y left, and then I divide by that. So I have 2x over 2 minus cosine y. Okay, and that's everything. It's done. Okay, so it's not that bad of a procedure, but it does take a little bit of practice. Hey, does anyone have any questions about that one?
Wait, when do you again put y and y?
Anytime you take a derivative of y.
She's gonna like.
So the 2y, why is it 2y, y?
Because the derivative of 2y is 2.
Okay.
So it's 2 times y prime.
Okay.
Okay? Okay. Oh, you better...
Oh, you're gonna be stuck in the hallway. Go
I mean, I don't know when it is, but it could happen. You should go.
If they get you, they won't get up.
It'll be you and Miss Larad stuck in an office forever.
Down here, I feel like I should know this one. But do you have to wait until the principal unlocks your door here?
I think they just make an announcement usually that are like, and it's over.
Oh yeah, they did that in William and in Sir John when I was there. And then
No problem.
the principal came around to all the classrooms and unlocked them. And the classrooms that were all sitting up because they like listened to the announcement all had to like
No, they're not going to do that to us.
because their reasoning for it was what if someone was in the office holding a gun to the
Oh, that's actually true. I've heard them say that before.
yeah.
But I still don't think we have to worry about it.
Okay.
Better like that.
Yeah, really. My classes are the classes that sat They're all like, okay, cool, we're done.
Actually, there's supposed to be, I remember they said it one year, there's supposed to be like a code word that the whole school knows, or at least that the teachers know, that so that when, like, if the lockdown's actually done, they can be like pineapple and everybody knows it's actually done, and that it's not that the secretary's being like threatened or whatever. Yeah. There's supposed to be a code word that we all know, so that, like, to end, there isn't one, but there isn't one that I know of, but there's supposed to be one, so that we know for sure. Oh, actually, I think there is something, it's supposed to be like, it's like, it's something with, like, it's a pun that involves Irish. It's like, I wish I was skiing, or something. It's something like that, it's something really stupid. Anyway. Basically, we're in trouble if anything happens. Okay, so we need to take, I'm going to do this one. This one isn't in your notes, but you should write it down. Okay, so this is a tougher one, but honestly, like, they don't really get harder as you keep adding stuff to them. They just get longer. So, but I want to show you this one because we haven't done very many that have x's and y's in the same term. So here, whenever I see x and y together like this, I know I'm going to have to do product rule when I get to it. So it's going to be a little bit harder. So Ryan, what's the first term going to be when I take the derivative?
4x.
Thank you, Ryan.
She asked me not able.
Oh, did she? I thought she said, what is it going to be? I answered. I'm sorry. I didn't.
Okay. Now for the second one, we have to do product rule. So f and g. So f would be 5x. And y squared would be g. So the derivative of 5x is 5 and times g, so 5y squared, plus, then I do g prime f. So personally, I actually do f g prime, so I would just write down 5x, and then I do g prime. What's the derivative of y squared going to be?
2y prime.
2y prime. Fantastic. Okay? So then I keep going. So anytime you take a derivative of y, you put y prime. So then I go minus, and I do the same thing. So this is f, this is g. So the derivative of f would be 12x squared. And g would just be y. And then I just put another minus, because I know it's going to be negative. And I do f g prime. What would g prime be here?
Y prime.
Y prime. So it's just y prime, like that. Okay, so you can see how long it's getting now. Ooh, that's not very good. That's okay, though. I don't have enough room. I'm just going to do it underneath. Okay, and then the final part, minus 3y cubed, would become minus 9y squared y prime. But yes, equals 0. Now, what you need to do is you need to collect all your y primes on one side and your non-y primes on the other side. So I just identify any term that has a y prime, and I leave them on this side. I would simplify this first one, the 5x times 2y prime. That's 10xy prime. Okay, then I have minus 4x cubed y prime minus 9y squared y prime equals, and I just move everything else over. So I always move the negatives first. So I would move the negative 12x squared y first, just because then I start with a positive. If there isn't any positives, then it's fine. Okay, minus 4, or it's even fine if you start with a negative. It's not like wrong. I just try not to. Okay, so there we go. Is everyone okay with me up to here? Now what do I do? Factor out a y prime. So I factor out y prime. If you want to skip this step, if you see how you could skip the factoring and just go right to the answer, go ahead. I don't actually do this step when I do it myself. I won't tell you how, but you can do it if you can figure it out. If it's obvious to you, then you won't do it wrong. Okay, and then you divide. If it's not obvious, just do the long way.
You can just not write it.
You could just not write it. If you think about it, like if you pull out the y prime, you can see what's going to be left, right? It's everything except for the y primes. Okay, there we go. So that's how you do this. It's quite a procedure.
Did you get numbers?
I got a combination of my sort of like.
Question.
Yeah.
For the